13 is a necessary assumption question. The argument relies on the assumption. So let's figure out this argument first. In early 2003, scientists detected methane in the atmosphere of Mars. Okay, so methane is a fragile compound, and it falls apart when when hit by UV. Right. So any methane, they say. So here's the conclusion. Right. Like from this point on, it's just okay. I guess I learned something about methane. It's very fragile when ultraviolet radiation from the sunlight hits it, and it falls apart. But in early 2003, we detected some methane in the atmosphere of Mars. So phenomenon, right? Phenomenon. So from this phenomenon, we're going to try to come up with a conclusion, hypothesis, explain it. The conclusion is any methane in the Martian atmosphere must have been released recently. Why? Why then, right? Like why? I mean, what we know is that, look, we found some methane. So we think, okay, methane exists in the atmosphere. And then this is the thing that we know about methane, is that it just falls apart when sunlight hits it. So from that, we conclude, it must be the case that any methane must have been relatively recently released. Why? Right? Because Mars had no methane prior to 2003? Why does that have to be true? What if Mars had methane prior to, December 1st, 2002, Mars also had methane? Right? What would that matter? I mean, we discovered it in early 2003, right? So I don't see how this is necessary. All methane in the atmosphere is eventually exposed to sunlight. See, this one is necessary. This one's necessary because if you negated this one, right, this is kind of what we were thinking anyway. Going from here over to this conclusion, if it gets hit by sunlight and falls apart, then you say, therefore any methane we detect, must have been recently released, right? Well, it must be that we expect it to at some point hit sunlight, right? So that's why, if you, so this is why this has to be true. Otherwise, if this were false, if you try to falsify this, then the premise won't support the conclusion anymore, right? It's not true that all methane eventually gets hit by sunlight, gets hit by UV rays. Well, if that's the case, then that means there's some methane that will never get exposed to sunlight, right? So if there exists methane that will never get exposed to sunlight, do you see how you take the negation of this, add it to this stuff? You can't say anymore. So any methane in the Martian atmosphere must have been recently released, because you could have had methane that's been lurking in the dark for thousands of years. Right? That's why B must be true. Otherwise, the premises lose all support for the conclusion. C says methane cannot be detected until it starts. But why not? I mean, what if we can detect methane before it starts falling apart? Right? Why would that do that wouldn't do anything to our argument. The methane that the scientists detected had been exposed to UV. No. I mean, it could have been intact methane. Right? The D is saying that fragments. We detected clues or signs of methane, so we say there once was methane because now it's exposed and fallen apart. But I mean, if you negate D, that doesn't hurt our argument at all. Methane in Earth's atmosphere does not fall apart as a result of exposure. Okay, that could or could not be true. Don't really care. We're talking about Earth's atmosphere, right? If it's true, if it's false, I don't see how this could be relevant to the argument.